There is a third way to deploy EKS worker nodes, and it's deploying self-managed worker nodes. Self-managed worker nodes are completely deployed and managed by our team, and AWS has no any responsibility to deploy the worker nodes, managing them, and controlling the life cycle of worker nodes. In the previous lessons, I explained how we can use fully managed node groups as well as manage node groups using custom launch templates. And in both cases, we learned that AWS is responsible for upgrading the worker nodes, dealing with all the OS upgrades, dealing with all the things related to worker node lifecycle, like cordon the nodes, draining the nodes prior to the upgrades, and it's the EKS service responsibility to manage the whole life cycle of your worker nodes. But in a self-managed worker nodes, you are completely responsible for managing all the things, to create launch templates as well as deploying worker node and dealing with worker node upgrades, dealing with zero downtime upgrade model, and anything related to worker node lifecycle. Let's get started. If you didn't join our social media, please follow our LinkedIn, Telegram, Facebook, Twitter, as well as YouTube channel. Why we need self-managed worker nodes? There are some use cases that make us to use self-managed worker nodes in EKS. For example, we are fan of managing everything by ourselves, or we want to customize worker node for some specific use cases and they cannot achieve by using managed base, or we want to use different cluster auto scaling strategies, because in a managed node groups, EKS service will create auto scaling group for our worker nodes. But in a self-managed way, we can create our customized auto scaling groups. Or we want to deploy some worker nodes outside AWS or in different regions, and we want to have and deploy a cluster with a different worker nodes in a different availability zone, different data centers, but you need to be where that it needs lots of work, and you need a good connectivity between data centers, between external data centers to AWS to make everything work. And in the case of deploying stateful applications, we don't suggest going and deploying a cluster with a different worker nodes in a different region, or outside your current region in a different a data center or outside AWS environment. But there are some use cases that you need to deploy your worker nodes outside this region, and in that case, self-managed worker node can provide you some solutions. So you need to consider something if you want to use EC2 auto scaling groups to create your worker nodes, and all the nodes within one auto scaling group should be used the same instance type. All of them should be running with the same AMI image, and all of them should use the same IAM node role. And the procedure is something we learned till today, because it's a mix of many things we explained in the previous lessons, and we want to add something new on top of what we learned till now. So the procedure is creating a different IAM role for our self-managed nodes. If we use managed node groups, it's really important to create a separate role for deploying self-managed worker nodes. And after that, we have to add that IAM role to a config map inside our Kubernetes cluster, AWS EKS config map, which provides the information of IAM roles. The ARN of IAM role can connect to the cluster and can use that IAM role to join to the cluster. I'll explain what really we have to do. And after that, we have to create an IAM instance profile and add the IAM node role for our self-managed worker nodes to that instance profile to be used within our launch template. And after that, when we want to create a launch template, we have to mention that instance profile. And after that, when the instance profile and the launch template is ready, and we have the final launch template, we can create our auto-scaling group to deploy actual instance to work as our worker nodes in EKS cluster. And then we can confirm that using kubectl command. So if you want to check what really happens, the first thing we need to do is to create a specific IAM role for our self-managed worker nodes. After that, we have to upgrade and update the config map inside our cluster. If you have no any worker nodes right now in your cluster, AWS EKS config map does not exist, and you have to create it. I'll show you how we can create that. And after that, we have to create an instance profile, and from the other way, we have to get the information from the latest available EKS image, finding the proper size of node, and finding the maximum path can be deployed to that instance type. And we have to fetch the cluster information and creating our cloud init user data file, and use the instance profile and our cloud init user data to create launch template. And when the launch template is ready, we can create our auto-scaling group. And by creating and deploying auto-scaling group, it automatically creates our worker node. And after deploying our worker node, they are coming up and joining to the cluster, and then we can use our worker nodes. So let's get started and create our IAM role for self-managed nodes. And we have to do that because when you deploy some worker node using managed node groups, AWS and EKS service automatically inject the IAM role ARN into your cluster into AWS EKS config map. And when you remove all the managed node groups and all the worker nodes deployed using managed node groups, AWS automatically remove that ARN from this config map. And it don't care about any self-managed worker node you deployed into your EKS cluster. So the thing is, when you create and you want to manage your worker node using managed node groups, AWS is responsible for upgrading and updating the information inside that config map. And when you have no any worker node deployed from managed node groups, AWS AWS automatically remove the IAM role from AWS Ask config map. And if you have some worker node deployed with self-managed way, you need to be aware of creating separate IAM role to avoid being removed by AWS EKS service. So it's really important to separate your IAM role used for managed node groups and the IAM role used for self-managed worker nodes. So to create that, we can follow part 3. And if you go a little bit down, we have to create our trust policy to allow EC2 service to be able to assume the role from within our instance. So to create that, we can create a trust policy. And after that, we have to create our AWS IAM role, but the name should be different. And I want to use something else. This is the name of our role. It's a self-managed, and I can change it here. So it mentioned I want to create a new role with the name Kubernetes EKS self-managed node group role, and I want to use that trust policy. If I try it here, it provides information that this role is already available because I created that before. And if we go to IAM service in roles, we can see the role is available. And the next step is to provide permissions and policies to our role, that you should change this information, and this information, and run all of them. Is something like what we created for managed node group, but we want to create a separate one to be used only for our self-managed worker node. So we can do that. We can do this one, and now it's done. And now we have our custom role for self-managed worker nodes. And then in the next step, we have to update that config map inside the cluster. If you check the cluster, AWS EKS update kube config, and the name of cluster is kubedemi. And now if we check within kube system namespace, you can see AWS alt config map is not available because right now we have no any nodes inside that cluster. But if you already deployed some worker node using other methods, you can see AWS alt config map is available and you can update it. But we don't want to do anything, just I need to edit and create a config map, and this information should be provided. So if you already have some worker node using managed ways, you should keep this role ARN and this configuration in your config map. But right now we don't need that, so we can create this config map. Okay, now if we check config maps, you can see we have AWS EKS config map. We need to create that, and this config map provides the information of the role can be used by kubelet to be able to join the cluster. So when we create our worker node using self-managed way, we assign that IAM role to our EC2 instances. And kubelet inside that EC2 instance wants to communicate with EKS control plane with our API server. And in that case, the communication and the authentication from kubelet to our API server will be managed and will be occur using that IAM role information. And from the cluster side, we have to grant access to the kubelet which use this IAM role and mention it's fine if the kubelet provides this information and it used this IAM role, it can communicate to cluster and it can join to our cluster. So it's really important to upgrade and update this config map within the cluster. The next thing is to create IAM instance profile. If you want to assign some IAM role to your EC2 instance, you need to create IAM instance profile, because directly you can't assign any IAM role to EC2 instances. And when we want to create EC2 launch template, we can mention the name of our IAM role. So we have to create instance profile and then add our IAM role to that instance profile. And when we want to create EC2 launch template, we can mention the name of that instance profile. And then when the node, when the instance coming up, it can use that IAM role we assign to instance profile. So to do that, we can use this command, and I can create my instance profile. It mentioned again that instance profile is available. If we check here, I think we have to check from dashboard, describe instance profile, get instance profile, and instance profile name should be this one. And as you can see, I already created that, and it provides you all the information about the roles. And right now, that role we created for our self-managed worker node is already assigned to this IAM instance profile. Now the next step is to add that IAM role to our instance profile. I already did it, but if you run this command, it provides you some information that right now we have it, and its limit is accessed, because when you create a instance profile, you can only assign one IAM role into that instance profile. So right now we have all the things, and now it's time to create EC2 launch template. In the previous lab, in the part 4, we created a custom launch template. We have to use the same thing and add something else, the IAM instance profile, into our launch template. So to create our custom launch template, we can follow part 4 of this course, and you can find the information. But the thing is, we have to do all the things like here. We need to create a security group, and I want to name it eCubedemy EKS SG custom launch template, and we can find the proper name I used here. And yes, I can use this one and provide SG cluster self managed custom launch template. And now we can run this command to create our security group. Security group is got created, and the next step is to allow the traffics between worker nodes within this security group to each other, and from the security group to cluster security group, and from the cluster security group to the security group, to allow communication between control plane and worker nodes themselves. So to do that, we can use, for the communication between worker nodes within this security group, we can use this information, and I have to change this one. Again, this is what we need to do. This is the first thing. After that, we have to authorize the communication between the cluster and worker nodes. To do that, we can find all the information. Now, if we check our EKS service, and if we check the cluster inside networking, you can find as a cluster security group is created for our cluster. We have to mention the information here and allow the communication between these two security group, as well as allowing access to the reverse access. We can provide the information here, something like that. And we can apply this one. We can apply this one. And now if we want to allow the communication from outside the network, from over the internet, for SSH access to our worker nodes, we can use this one and allow communication to our worker nodes. And now if we go to our security groups and check all the security groups, you can see we have some rules here which allows the communication we want. So we have all the things here. It's fine. And the next step is to find EKS optimized AMI. If you're not familiar with this part, it's good to watch the previous part 4 on YouTube, and you will find all the information related to what we need to do to create custom launch template. Because in that video, I explained about all the steps to finding the optimized image, why we need them, and other information you need to create your custom launch template and learn about what is custom launch template and why we need them and other information. So right now I have to find the latest EKS image for Kubernetes 128. This is our AMI image. Now we have to find the cluster information. We get the cluster information. This is our cluster information. API server address. We need to get certificate authority data. This is our certificate authority data. And I have it here. We have to find service CIDR block to create core DNS IP address, and when it's our service CIDR block, the 10th IP is our core DNS. This is the core DNS IP address. This is service IP address for core DNS. And the next step is to find the maximum number of pods can be deployed into the worker node because of the limitation in number of network interfaces, and the number of IP addresses can be assigned to each network interface. So we have to download some tools and download the script provided by AWS to find maximum number of pods. And after that, we have to run this script and provide the instance type we want to use for our worker nodes, as well as VPC CNI version. If you want to use any other CNI, you need to change some configuration inside your custom launch template. But right now we want to use VPC CNI, and because of that, we have to find the proper and the maximum paths can be run within that instance type. So if I run this command, you can find this is the maximum number of max pods per node for T3 medium instance type. And after that, we have to create our cloud init user data, and within that user data, we have to provide the information, the cluster, API server, certificate authority information, and core DNS IP address. And as you can see, right now it's already available. And the next thing is the maximum paths can be run within that node. So we have to create our user data, And after that, it's time to create our EC2 launch template. To create EC2 launch template, you should follow this one. And as you can see, I want to use this AMI. It should be the same. And I want to use T-Terry medium instance type. And we have to get our user data information from here. And we need to provide the proper security group. This is our security group for self-managed worker nodes. This is our security group. And now, as a part of our launch template, we have to mention IAM instance profile. And it provides the name of instance profile we want to assign to our EC2 instances. And you should be aware that the tag specifications should not be provided when we want to use them for self-managed worker nodes, and we have to set and assign IAM instance profile. So let me create this file first. The launch template is fine. We mentioned all the information. Create that again. Okay, it's fine. And now we have to create our custom launch template. Custom launch template is ready. If we check inside our EC2 service in launch templates, you can see it's ready to use. And in advanced detail, if you check the user data, our information about how worker node should bootstrap and running the bootstrap sh file, the bootstrap script is available here. And now it's time to deploy our worker nodes. In the previous part, after creating the custom launch template, we used EKS service and create our node group using semi-managed model, and inside AWS EKS create node group command, we provide our launch template. But right now, when we want to deploy self-managed worker nodes, we don't use AWS EKS create node group command. And the difference between this model and the model I mentioned in this part is when we have the launch template in self-managed way, we have to create auto-scaling group. And then the worker node will be created by that auto-scaling group. And when we can create the auto-scaling group, it means we can customize it. But in managed way, when we create our launch template, we use that template and we provide the template name to EKS service, and EKS automatically create that auto scaling group. So we can customize the auto-scaling group created by EKS service. But in self-managed way, we can do that. So right now we have the launch template, and it's time to create our scaling group. Inside our scaling group, by running this command, you can see we can create our auto scaling group, and we can provide our subnets. We can configure anything related to that scaling group configuration to customize everything we want, and then we can run this command. So by running this command, it creates auto scaling group, and if we go to auto scaling group, you can see the auto scaling group is get created, and by creating the auto scaling group, as we mentioned, we need 2 nodes. If we check the instances, you can see 2 nodes is coming up, and if I go to this part, after some time, we can see all the information here. And let me check for the clusters. After some time, these instances will join our Kubernetes cluster, and we can get the information from our kubectl command line. If we check, as you can see, we deployed 2 self-managed worker nodes, and right now they are ready to be used. So they are ready, it's running, and now if we want to deploy anything, for example, we can create deployment nginx image nginx alpine replicas 1, and if we check our part is ready, so we can start using self-managed worker nodes inside the cluster. And this is what we did in this part to deploy EKS worker nodes using self-managed worker nodes method.